The Great Pyramid is a mystery that should not exist. Ancient builders achieved a precision that defies our understanding of their time. This video uncovers the hidden legacy of knowledge that allowed forgotten civilizations to measure the Earth and map the stars. You will discover a unified science of the cosmos, a lost human potential encoded in stone. How did they grasp celestial patterns with such stunning accuracy? And what profound truth about our past is still waiting to be decoded? What does it mean to rediscover a forgotten chapter of human ingenuity? Long before the pyramids, the first great stone circles rose from the earth. A single surveyor could mark out a perfect ring using nothing more than a length of rope and a central stake. This was the birth of megalithic metrology, the ancient science of measurement. These forgotten builders did not work by guesswork. They operated with a standardized system of units, a common language of length that allowed them to create monuments of breathtaking precision across vast distances. The most famous of these units is known as the Megalithic Yard. It was not an arbitrary length. Researchers like Alexander Thom found evidence of its use from Scotland to Brittany, a consistent measure of roughly 2.72 of our modern feet. How was such a standard maintained across thousands of miles and centuries? The answer may lie in the heavens or in the human body itself. Perhaps it was derived from the swing of a pendulum, a natural rhythm that produces a consistent length. Or maybe it was based on astronomical calculations, a small fraction of a degree on the horizon. This reproducible system was the foundational tool. It transformed chaotic landscapes into ordered geometry. With it, they could lay out perfect circles, ellipses, and complex alignments with nothing but stakes and rope. The true purpose of this precision was far greater than mere construction. These standard units allowed them to encode astronomical knowledge into the very bones of the Earth, creating structures that acted as calendars and observatories. The existence of such a sophisticated system hints at a coordinated, purpose-driven civilization, one that saw measurement as a sacred link between humanity, the Earth, and the cosmos. A perfect beam of golden light pierces the inner darkness of a 5,000-year-old tomb, illuminating a chamber untouched by the sun for an entire year. This is Newgrange in Ireland, a masterpiece of stone and earth designed to capture a single, precious moment, the winter solstice sunrise. The builders did not merely observe the sky, they forged a permanent bond between architecture and astronomy. Across the Atlantic at Choco Canyon, a dagger of sunlight slices between two stone slabs, striking a spiral petroglyph to mark the summer solstice with the same unwavering accuracy. These structures were more than tombs or temples. They were humanity's first permanent calendars, stone clocks synchronized with the cosmos. The principle behind them is both simple and profound. The ancient surveyors learned to translate the grand, cyclical motions of the sun, moon, and stars into fixed terrestrial alignments. They understood that a specific point on the horizon, like a distant notch between two hills, would only be touched by the rising sun on one particular day of the year. By building a doorway or a window that precisely framed that point, they captured that celestial event in stone for eternity. This required more than just a standard unit of length. It demanded a deep understanding of angles and a long-term, recorded knowledge of celestial mechanics. They were tracking cycles that take decades, even centuries, to complete. How did they achieve such precision without written records as we know them? The answer lies in the monuments themselves, which served as both observatory and data storage. The knowledge of when to plant, when to harvest, and when to conduct sacred ceremonies was not written on fragile parchment, but etched into the landscape with a permanence that has survived for millennia. This was a deliberate, concerted effort to harmonize human life with the universal rhythm, a concept of cosmic order that would be pursued and refined for thousands of years to come. Centuries before Pythagoras was even born, a Babylonian scribe pressed his stylus into wet clay, recording a principle that would one day bear a Greek name. The tablet known as Plimpton 322 is not a theoretical exercise. It is a practical table of numbers listing pairs that form the sides of right-angled triangles. This artifact, over 1,000 years older than the man himself, demonstrates a working knowledge of the relationship we call the Pythagorean theorem. The Babylonians were not alone. The ancient Egyptians used this same principle with stunning practicality. To re-establish the perfect corners of their fields after the Nile's annual flood, surveyors known as rope stretchers employed a simple but infallible tool. A rope knotted into 12 equal segments could be stretched into a triangle with sides of 3, 4, and 5 units. When pulled taut, the angle between the 3 and 4 unit sides was guaranteed to be a perfect right angle. This was not abstract math for them. It was the bedrock of agriculture and architecture, a way to bring order back from chaos. The same geometric rigor is found in the construction of fire altars in ancient India, described in the Sulba Sutras. These texts provide detailed instructions for building square platforms and altars of specific areas, requiring a masterful understanding of how to combine shapes and manipulate right angles to achieve precise dimensions. The evidence is overwhelming. A sophisticated understanding of geometry was not a sudden invention in classical Greece. It was a widespread, practical toolkit developed by multiple ancient cultures to solve real-world problems. They were building, surveying, and creating with a mathematical confidence that we only later formalized into theorems and proofs. This shared knowledge hints at a deep, interconnected web of practical wisdom, a common foundation of engineering insight that spanned continents and millennia, waiting to be rediscovered. Eratosthenes of Alexandria stands in the noonday sun, his shadow a short, dark line at his feet. He knows that on this day, at this very hour, the sun shines directly down a deep well in the city of Seen, hundreds of miles to the south. Here in Alexandria, his shadow tells a different story. By measuring the angle of that shadow, a mere 7 degrees, and knowing the distance between the two cities, he performed a feat of logic that would echo through history, calculating the Earth's circumference with astonishing accuracy. But a profound question lingers. Was he truly the first, or was he the last inheritor of a much older tradition? The evidence carved in stone across the globe suggests a far more ancient awareness of our planet's true shape and size. Consider the placement of the Great Pyramid at Giza. It sits almost exactly on the 30th parallel north, a line of latitude that divides the Earth in a mathematically significant way. This is no random coincidence. From the pyramids to the sacred city of Angkor Wat, key ancient sites appear to be positioned on a global grid of significant latitudes, as if their builders understood their precise location on a spherical Earth. Even more compelling are the dimensions encoded within the monuments themselves. The perimeter of the Great Pyramid, for instance, relates to the planet's circumference in a simple ratio. If you take its base perimeter and multiply it by 43,200, a symbolic number representing the number of minutes in a 360-degree circle, the result is a figure remarkably close to the Earth's equatorial circumference. Could this be chance, or is it the signature of a lost science of Earth measurement? Some researchers propose that a primordial system of geodetic knowledge existed, a unified understanding that allowed these forgotten builders to see their local sacred sites as points on a global body. This was not about navigation in the way we think of it today. It was about placing humanity within the cosmic order, anchoring their temples to the very dimensions of the world. This global perspective, this understanding of their place on the sphere, was the crucial foundation for their ultimate ambition, a project that would require them to look far beyond the Earth itself. The slow drift of the stars presents a mystery on a scale almost impossible to grasp. Our planet spins like a wobbling top, its axis tracing a lazy circle in the cosmos over a cycle of 26,000 years. This is the precession of the equinoxes, a grand celestial clock whose tick is so slow that a single human lifetime witnesses only the smallest fraction of its movement. To detect this drift requires more than a single generation of sky watchers. It demands a sacred duty passed down through centuries, a commitment to record observations with unwavering precision for a reward none of the original observers would ever live to see. Yet, astonishingly, myths and texts from cultures separated by oceans speak of this great year. The ancient Greeks wrote of a golden age returning with the completion of a cosmic cycle. Hindu cosmology describes 4 world ages, or yugas, that cycle over immense periods. The Maya calculated long-count calendars that resonate with these precessional rhythms. Were these just philosophical metaphors, or were they the echoes of a hard-won astronomical truth? The evidence may be written in stone. The 3 pyramids of Giza are arranged on the ground in a pattern that eerily mirrors the 3 stars of Orion's belt, but not their alignment in our modern sky. Instead, the layout matches the precise orientation of that constellation, as it would have appeared in the sky over 10,000 years ago, at a specific point in the precessional cycle. On the other side of the world, the vast temple complex of Angkor Wat in Cambodia is laid out as a terrestrial map of the constellation Draco, again corresponding to its position in the ancient sky. These are not simple alignments to the sun or moon. They are snapshots of the night sky frozen at specific moments in a 26,000-year journey, requiring their builders to understand that the very canopy of heaven was in motion. What kind of society could sustain the intellectual continuity to make such an observation? It implies the existence of stable, long-term institutions, perhaps priestly colleges or mystery schools, dedicated solely to the preservation of celestial data across hundreds of generations. Their cosmology was not just about the seasons, it was about humanity's place in a vast, turning universe. This long-term vision of time suggests a civilization that saw itself as a fleeting part of a cosmic story, a perspective we are only just beginning to reclaim. A Gothic cathedral window and a Hindu temple floor plan, separated by continents and centuries, share a secret mathematical language. Both are built upon the same timeless ratios, a code of sacred geometry that ancient builders saw as the very fabric of creation. The most famous of these is the golden ratio, approximately 1.618 to 1. This proportion appears throughout the natural world with an insistent frequency. It dictates the graceful spiral of a nautilus shell, where each chamber grows in perfect proportion to the last. It governs the arrangement of seeds in a sunflower head, packing them with maximum efficiency along spiral arms that count out numbers in the famous Fibonacci sequence. It is even found in the branching of our own veins and the proportions of a DNA molecule. For the ancients, this was not a coincidence. It was evidence of a universal blueprint, a divine harmony that infused all of life. They believed that by incorporating these same proportions into their temples and monuments, they could build structures that were not just shelters, but living resonators of cosmic order. The Great Pyramid of Giza is a stunning example. The ratio of its perimeter to its original height is a close approximation of 2 times pi, the mathematical constant that defines the relationship between a circle's circumference and its diameter. This means the builders encoded the fundamental principle of the circle into the very form of a square-based pyramid. This was a profound philosophical statement. It was an attempt to square the circle, to unify the earthly and the celestial within a single, perfect geometric form. In medieval Europe, master masons used these same principles to raise their cathedrals to the heavens, believing the geometry itself would channel divine presence into the sacred space. This goes far beyond simple aesthetics. It reveals a world view where number, shape, and ratio were the language of the cosmos. Human creation was at its most perfect when it consciously mirrored the patterns found in a seashell, a galaxy, or the human body. By building according to this sacred code, they were not just constructing buildings, they were composing a hymn in stone, aligning their works with what they perceived as the eternal and intelligent design of the universe. The Roman foot, the Sumerian cubit, and the Egyptian royal cubit feel like separate inventions from isolated worlds. Yet when you place these ancient rulers side by side, a strange pattern emerges. They are not random lengths, they appear to be different expressions of a single, forgotten standard. The Egyptian royal cubit measured about 20.62 inches. The Mesopotamian cubit was strikingly similar. Even the Greek foot and the Roman foot can be shown to relate to this cubit through simple fractions. This is not a loose resemblance. It is a precise mathematical relationship, as if each culture was using a different-sized measuring cup from the same universal set. How could civilizations separated by deserts and seas, by language and gods, arrive at such a harmonized system of measure? One compelling theory points to a common ancestral source, a primordial standard of length that was carried across the world by the first great migrations. Another possibility is a network of trade and knowledge exchange far more extensive than we have ever credited to the ancient world. Skilled artisans, the master builders and surveyors, may have been the international couriers of this practical science. They carried their tools and their measuring rods from one great project to the next, from the banks of the Nile to the valleys of the Indus. This was not just about buying and selling goods. It was about transferring a technology of precision. The implications are staggering. The existence of a shared measurement system implies a shared scientific language. It means a builder from Egypt could have understood the blueprints of a temple in Mesopotamia. It suggests a level of global interaction and intellectual cooperation in the deep past that our history books have barely begun to acknowledge. This was not a world of isolated genius. It was a world connected by a common thread of cosmic understanding, a thread woven from the very dimensions of the earth itself. These silent stone giants were never meant to be mere tombs. They are the most durable libraries ever conceived, their shelves the very angles and corridors, their texts written in geometry and alignment. The Great Pyramid of Giza is perhaps the ultimate example of this stone language. Its base perimeter, when compared to its original height, produces a ratio that is essentially 2 times pi. This is not an approximation a stonemason might guess. It is a precise mathematical constant deliberately encoded into the structure's very form, a constant that defines every circle in the universe. The builders were making a profound statement, embedding the principle of the circle within the shape of a square. This is high-level mathematical philosophy rendered in limestone and granite. Across the ocean, the city of Teotihuacan in Mexico whispers the same coded message. The layout of its central avenue and major pyramids, like the Pyramid of the Sun, appears to be a scaled model of our solar system. The distances between these structures correspond with stunning accuracy to the orbital distances of the planets from our Sun. How could a civilization without telescopes possibly know such things? The answer may be that they were not mapping the solar system as we see it. but rather encoding a different, more symbolic understanding of cosmic harmony, using the same universal constants. This was a language built to last. Papyrus burns, clay shatters, languages are forgotten, but a mountain of stone, precisely aligned to the stars and built with mathematical truths, can endure for millennia. It is a testament to incredible foresight. These builders were not just working for their own generation. They were planting a seed of knowledge in the most resilient vault they could imagine, the Earth itself, ensuring that even if their names were lost, their deepest understanding of the cosmos would one day be read again. This knowledge was far too precious to be left to chance. Behind every perfectly aligned stone and precisely calculated angle stood a disciplined mind, a member of an intellectual elite forged not in public forums, but in the secluded halls of initiation schools. These were the mystery schools of Egypt, the Druidic orders of Europe, and the Vedic Guru lineages of India. Within these protected environments, the sciences of astronomy, geometry, and geomancy were not merely academic subjects. They were sacred trusts, a form of power that required not just intelligence but profound moral and spiritual preparation. The initiate did not just learn formulas. They underwent a transformation, learning to see the world through a lens of sacred number and cosmic rhythm. The secrecy was not for selfish reasons, but to protect the integrity of the knowledge itself. In a world without printing presses or digital storage, an error in a key astronomical constant could corrupt a tradition for centuries. By controlling the passage of this wisdom through rigorous oral tradition and direct mentorship, these societies acted as living libraries, ensuring that the standard of the cubit or the cycle of precession was transmitted with flawless accuracy from master to apprentice. This created an unbroken lineage of adept architects and astronomers. A master mason working on a cathedral in France was the spiritual and professional descendant of a pyramid builder on the Giza Plateau, even if they were separated by thousands of years. They shared a common vision, a common language of measurement, and a common purpose to build structures that would harmonize human society with the universe. The grand projects were not commissioned by kings alone, but directed by these hidden hands, these keepers of a cosmic blueprint. Their goal was to maintain cosmic and social order, believing that a properly aligned temple or city would channel benevolent forces into the world, ensuring fertility, stability, and divine favor. This was the ultimate purpose of their secrecy, to safeguard the tools for building a world in balance. While master builders were encoding cosmic truths in stone, another group of adventurers was using that same knowledge to conquer the greatest wilderness of all, the open ocean. Without a single compass or chart as we know them, Polynesian voyagers embarked on journeys across thousands of miles of trackless Pacific. They were not drifting aimlessly. They were navigating with a science so refined it allowed them to find specks of land in an immense blue desert. Their secret was a living map written in the stars, the waves, and the flight of birds. They memorized the star paths, knowing which specific stars would pass directly over their destination islands. They watched for the zenith passage of the sun. The one day a year it shone straight down into a special calabash of water, telling them they had reached the correct latitude. They learned to read the ocean swells, feeling the subtle deflection of waves as they bounced off distant, unseen islands, a rhythm they could interpret through the hull of their canoe. This was a dynamic, real-time application of celestial measurement. Far to the west, the Phoenicians, the master mariners of the Mediterranean, used similar techniques. They famously sailed at night, guided by the North Star, which they knew as the star that did not move. They ventured beyond the Pillars of Hercules and down the coast of Africa, their success relying on an intimate understanding of the sky's relationship to the spherical Earth. Meanwhile, the Vikings were crossing the North Atlantic, using a sun compass and a mysterious crystal known as a sunstone to locate the sun's position even on overcast days, allowing them to plot a course to Iceland, Greenland, and eventually the shores of North America. What unites these disparate cultures is a shared, profound realization. They did not see the Earth as a flat plane. Their very method of wayfinding depended on a mental model of a spherical world, where the heavens rotated above them in a predictable, mappable dome. To navigate by the stars is to accept that you are on a globe moving through a cosmos of constant turning. These voyages were the ultimate test of the ancient world's geodetic knowledge. They were not just exploring new lands, they were proving a concept, demonstrating through daring action that the abstract principles of cosmic order could be used to physically traverse the planet. Their canoes and longships were the mobile, practical extensions of the stone observatories left on shore, applying a universal science to the greatest exploration the world has ever known. The scent of burning papyrus is the ghost of 1,000 lost voices. When the Library of Alexandria fell, it was not just a building that was destroyed, but a central node in the global network of ancient knowledge. The works of Hipparchus, the man who first mapped the stars and detected the slow wobble of precession, were reduced to ash. The original calculations of Eratosthenes, likely far more detailed than the summaries that survived, vanished forever. The geographical surveys of Posidonius, who also attempted to measure the Earth, were lost to the flames. This event stands as a powerful metaphor for a far greater and more gradual tragedy, the fragmentation of a once unified cosmic science. What we consider today as isolated marvels, like the pyramids or the star clocks of Choco Canyon, were likely just local expressions of a common body of knowledge that spanned the globe. Imagine trying to reconstruct a symphony after 99% of the sheet music has been destroyed. You might find a single page with a beautiful violin solo and another fragment with a powerful drum rhythm. You could study these isolated pieces and admire their individual genius, but you would have no concept of how they harmonized into a single, overwhelming composition. That is the position we are in with the ancient world. The surviving texts are those fragments. The monuments are the echoes of that grander symphony. How much more did they know? Did they possess star charts that mapped the precessional cycle in its entirety? Did they have a complete geodetic survey of the planet, explaining the precise placement of sacred sites on a global grid? The silence left by that lost library is deafening, and it forces us to look at the silent stones with a new and more profound sense of wonder. The real library was never contained within four walls. It was written into the alignments of temples and the proportions of pyramids, a distributed, fireproof archive waiting for a future generation to learn its language. A laser theodolite hums quietly as it projects a perfectly straight line through the long, dark passage of a 5,000-year-old tomb. This is Misho in Orkney, a monumental cairn built to capture the last rays of the setting sun on the winter solstice. For centuries, this was local legend, a story passed down. Now, with satellite data and precision instruments, we can confirm it. On the shortest day of the year, a beam of light pierces the entrance tunnel and strikes the rear wall of the central chamber with the accuracy of a modern laser pointer. There is no maybe, no approximation. It is a feat of engineering designed to mark a specific celestial event with absolute certainty. This is the power of astroarchaeology, a field that replaces speculation with measurable, verifiable data. Across the sea at Stonehenge, the purpose of its long avenue has been debated for generations. Modern surveys reveal its alignment is not with the solstice sun, but with the most extreme rising point of the moon, an event known as the lunar major standstill. This cycle takes 18.6 years to complete. To encode this into the landscape required observations sustained over multiple human lifetimes, a commitment to a pattern far slower than the annual rhythm of the seasons. When we map these sites with GPS and recreate ancient skies with planetarium software, we are not imposing our modern ideas onto the past. We are reading the intentions the builders themselves carved into the earth. The evidence is overwhelming and consistent from the pyramids of Egypt to the sun daggers of Choco Canyon. These alignments are not random. They are statistically significant, repeated, and precise. This scientific validation forces us to confront the sheer scale of their ambition. They were not simply marking time. They were building a permanent, stable cosmos here on Earth, a reflection of the heavenly order they observed above. The stones themselves are the final proof, and our technology is finally allowing them to speak their truth with a clarity we can no longer ignore. A corroded lump of bronze and wood, hauled from the depths of a 2,000-year-old shipwreck, held a secret that would shatter our timeline of technological progress. This is the Antikythera Mechanism. When its encrusted fragments were painstakingly analyzed, researchers found not a simple statue or tool, but an intricate clockwork of at least 30 interlocking bronze gears, housed in a wooden case no larger than a shoebox. This was not merely a calendar, it was a mechanical universe in a box. By turning a hand crank on the side, an ancient user could advance the device through time, watching as tiny pointers representing the sun, the moon, and known planets moved across dials marked with the constellations of the zodiac. It could predict solar and lunar eclipses with remarkable accuracy, and it even included a small dial that tracked the 4-year cycle of the Olympic Games. Its complexity is staggering, a level of miniaturized precision engineering that we would not see again until the mechanical clocks of 18th century Europe. The existence of this single device forces a complete rewrite of history. It proves that the ancient Greeks, and likely other cultures they traded with, possessed a mechanical genius we never credited them with. They had moved beyond observing the cosmos to building a working model of its motions. The gears themselves were a physical expression of their mathematical theories, a tangible proof that they understood the cyclical patterns of the heavens well enough to replicate them in bronze. This was not just philosophy, it was applied cosmic science. The Antikythera Mechanism stands as a lonely survivor, a single page from what must have been a vast library of lost technology. It is a haunting clue. If one such device was being transported across the Mediterranean, how many others were built? How many similar analog computers, perhaps even more advanced, were lost to the fires of libraries, the decay of wood, or the crushing pressure of the sea? This one artifact suggests a technological peak, a brief flowering of a mechanical age that was almost entirely erased from memory, leaving behind only silent stones and this one miraculous corroded key. The gears of the Antikythera Mechanism were not the only way ancient minds encoded cosmic data. Long before such devices were built, humanity's most powerful storage system was the story. We have long separated myth from history, placing tales of gods and floods in the category of fiction. But what if this is our own failure of imagination? What if these stories were never meant to be taken literally, but were instead a sophisticated vehicle for transmitting hard-won scientific knowledge in a memorable oral format? A global flood narrative found in hundreds of cultures, from the Mesopotamian epic of Gilgamesh to the Genesis account to indigenous traditions in the Americas, is a prime candidate. For generations, we interpreted these as mere moral parables or pure invention. Yet, modern geology confirms that the end of the last ice age was a period of catastrophic global change. Vast ice sheets melted, sea levels rose by hundreds of feet, and entire coastal civilizations would have been swallowed by the rising waters in a span of generations. This was not a single 40-day event, but a protracted, world-altering trauma. The global flood myth could be the enduring memory of that real geological catastrophe, a warning passed down for thousands of years about the power of a changing climate. Similarly, the Greek poet Hesiod wrote of the 4 ages of man, a cycle that progresses from a golden age through silver and bronze to our current Iron Age. This reads like a philosophical metaphor for moral decline, but when viewed through an astronomical lens, it maps perfectly onto the great year of precession, the 26,000-year cycle of the equinoxes through the 12 constellations of the zodiac. Each age, lasting roughly 6,500 years, corresponds to the Sun's position at the spring equinox, moving through one of the 4 fixed signs of the zodiac: Taurus, Leo, Scorpio, and Aquarius. The myth becomes a poetic but precise celestial clock, the story of Phaeton, who lost control of his father Apollo's sun chariot and scorched the earth, reads like a dramatic fable about hubris. But could it be an allegory for a close pass of a comet or a dramatic solar flare, an event that left a tangible mark on the global climate and was seared into collective memory? These narratives were not lies. They were the most robust data storage system available, designed to survive the collapse of languages and the burning of libraries. The rhythm of an epic poem, the drama of a hero's journey, these were the hooks that ensured the survival of critical information about planetary history, celestial cycles, and past cataclysms. The myth was the medium, and the message was a warning and a record written not on clay but on the human soul. A straight line drawn on a map can connect a stone circle in England to a medieval church, and then onward to a prehistoric burial mound. This is the seductive idea of the ley line, a network of invisible threads said to stitch the ancient landscape into a single, purposeful design. The concept emerged a century ago, proposed by an amateur archaeologist who noticed that many old sites fell into startlingly straight alignments for miles across the countryside. The immediate question is one of probability. Are these lines evidence of a lost blueprint, or are we simply seeing patterns in a crowded landscape where any random set of points will eventually create a straight line? Statistical analyses often land on the side of skepticism, suggesting that with enough ancient sites dotting a map, such alignments are almost inevitable. Yet, the sheer number of these lines and their persistence in local folklore is difficult to dismiss entirely. This leads to a deeper, more compelling idea: the practice of geomancy. This was not merely about drawing straight lines between points. It was the belief that the Earth itself is a living body, pulsing with subtle energy currents. Ancient surveyors, often called dowsers, might have used simple forked rods or pendulums to detect these telluric forces, these streams of Earth power. They sought out powerful nodes, places where these currents crossed, and there they built their most sacred structures. Whether these energies are a physical force we have yet to measure or a symbolic concept of spiritual potency, the outcome on the ground is the same. Sacred sites from the Himalayas to the Andes are frequently found atop natural aquifers, atop specific geological faults, or at the confluence of underground water streams. The location was never arbitrary. It was always a deliberate choice to build at a place of perceived power. This suggests a worldview where the landscape was not just a resource to be used, but a partner to be harmonized with. The placement of a temple or a stone was an act of acupuncture on the body of the earth, an attempt to stabilize and enhance these natural energies for the benefit of the entire community. The ley line, then, whether a literal energy conduit or a symbolic pathway, represents a holistic vision. It connects the sacred site to the horizon, to its celestial alignments, and to the deep, unseen currents of the planet itself, weaving a single, integrated tapestry of sky, stone, and earth. Even the most brilliant civilization is built upon a fragile foundation of stable weather and predictable harvests. A single generation of famine can unravel the work of centuries, scattering the learned elite who once tracked the slow dance of the stars. The annals of archaeology are filled with such disappearances, where sophisticated knowledge seems to vanish almost overnight. The culprit was often a dramatic shift in the climate itself. Around 4,200 years ago, a mega drought known as the 4.2 kiloyear event gripped vast regions of the planet. From the Fertile Crescent of Mesopotamia to the Indus Valley, great cities that had flourished for 1,000 years were suddenly abandoned. The Akkadian Empire, one of the world's first great empires, collapsed into a dark age. Canals silted up, trade routes fell silent, and the specialized class of scribes and astronomers who depended on a food surplus simply could not be sustained. Their knowledge, written on clay tablets, was buried by the very sand that reclaimed the fields. This was not an isolated event. Centuries later, the cataclysmic eruption of the Thera volcano shattered the Minoan civilization on Crete. The blast was orders of magnitude greater than Krakatoa, sending tsunamis across the Mediterranean and plunging the region into a volcanic winter that would have lasted for years. The sophisticated palace culture of the Minoans, with its advanced architecture and likely celestial knowledge, was crippled beyond recovery. Their legacy was passed down only in fragmented myths, perhaps inspiring the story of Atlantis. But what of an even greater catastrophe? A controversial but compelling theory points to the Younger Dryas period, around 12,800 years ago. The hypothesis suggests that fragments from a disintegrating comet struck the Earth's northern ice sheet, triggering a sudden and brutal return to Ice Age conditions right as the planet was warming. This cosmic impact would have generated continent-wide firestorms, followed by a centuries-long deep freeze. It is a scenario that could have wiped out entire cultures, hunter-gatherer or otherwise, that had developed a sophisticated understanding of their world. Imagine a society that had mapped the precessional cycle, only to have every living keeper of that calendar perish in a single terrible day, their knowledge atomized into myth. This pattern of rise and fall, of innovation and amnesia, suggests that human history is not a simple, upward-sloping line of progress. It is more like a spiral where techniques are perfected, lost in a cataclysm, and then slowly, painstakingly, rediscovered millennia later by people who have no memory of the original discovery. The pyramids stand, but the blueprint is gone. The myth of a great flood endures, but the geological data behind it is forgotten. Each collapse forces humanity to start again, rebuilding not from scratch, but from the scattered, enigmatic ruins left by their infinitely clever predecessors. A forgotten manuscript arrives in a Venetian port, its pages filled not with gold leaf, but with geometric diagrams copied by an Arabic scribe centuries before. This was the spark. The European Renaissance, often celebrated as a sudden explosion of human genius, was in large part a great remembering. For centuries, while Europe was fragmented, Islamic and Byzantine scholars had been the diligent librarians of antiquity, preserving, translating, and expanding upon the works of the Greeks. They safeguarded the astronomy of Ptolemy, the geometry of Euclid, and the physics of Archimedes. When these texts finally flowed back into the West, it was like a dam breaking. A lost continent of thought was suddenly remapped, and it gave European thinkers a new vocabulary for the cosmos. Copernicus, grappling with the clumsy mechanics of the old Earth-centered model, found his revolutionary idea in the forgotten speculations of Aristarchus of Samos, who had proposed a sun-centered system over 1,000 years earlier. He was not inventing from nothing. He was reanimating a classic idea with new observational rigor. Johannes Kepler, searching for the harmony behind planetary motion, fused this recovered Greek geometry with Tycho Brahe's precise data to discover his laws of planetary motion. He was driven by a belief that God had designed the universe according to geometric principles, a concept straight from the playbook of Pythagoras and Plato. This was not a rejection of the past, but a collaboration with it across time. The very tools that enabled the age of exploration, the astrolabes and improved maps, were direct descendants of this recovered knowledge. Our modern scientific worldview, with its emphasis on mathematical law and observable fact, was not born in a vacuum. It is built upon a foundation quarried in deep antiquity, a foundation we only rediscovered because other cultures had the foresight to keep its blueprints safe. The Renaissance stands as a monumental testament to a powerful truth. Knowledge, even when seemingly lost, can lie dormant like a seed, waiting for the right conditions to bloom once more and transform the entire world. This gives our own search for a lost prehistoric science a profound sense of hope. What other seeds of understanding are still buried, waiting for us to learn how to read the land itself? The universe may be the ultimate hologram, a vast projection where every small part contains the information of the whole. This startling idea from modern theoretical physics finds a strange and beautiful echo in the oldest human beliefs. Ancient cosmology spoke of a fundamental unity, the principle of as above, so below, where the grand patterns of the cosmos were mirrored in the smallest details of life. They saw the world as a living fractal, a design repeating from the spiral of a galaxy to the whirl of a seashell. Today, scientists exploring the nature of reality describe a universe woven from a single, unified field, a cosmic fabric where everything is interconnected. The vacuum of space is not empty but seethes with potential energy, a geometrically structured ground of all being. This is not so different from the ancient concept of a sacred geometry underpinning creation, a world built from number and ratio. The builders who encoded pi into a pyramid were not doing primitive math. They were expressing a profound intuition about a coherent, intelligible cosmos. Our most advanced quantum models now suggest that spacetime itself may be composed of tiny, discrete packets of information, a pixelated reality that operates according to mathematical laws. The ancient pattern seekers, gazing at the stars and measuring the Earth, were sensing this same deep structure. They perceived the universe as a single, conscious entity, and they built their monuments to resonate with its fundamental harmony. This is not a claim that they possessed our mathematics or our instruments. It is a recognition that their mode of thought, their relentless search for the unifying patterns behind the visible world, is leading them toward a truth that our own science is only now, with all its sophisticated tools, beginning to formally describe. The gap between the mystic and the physicist narrows when both are reading from the same cosmic blueprint, one through sacred intuition and the other through rigorous experiment, yet both arriving at the same stunning conclusion, that we live in a universe of profound and beautiful order. A single chant, perfectly recited, could carry a star map across 1,000 years. In an age before hard drives and printed books, human memory was the most durable library ever built. This was not a simple act of rote memorization. It was a sophisticated technology, a system of mental architecture designed to preserve complex data with the precision of a computer code. The secret lay in transforming raw information into a story, a rhythm, a song. The human brain is wired for narrative and melody. Facts recited in a monotone are easily forgotten, but the same facts woven into an epic poem, set to a specific meter, and accompanied by a ritualized performance become almost impossible to lose. The Vedic hymns of ancient India are a stunning example. These sacred texts, some over 3,000 years old, were passed down orally for countless generations before ever being written on palm leaves. The priests who memorized them used intricate techniques, including tonal accents and complex rhythmic patterns, as a built-in error correction system. A single mispronounced syllable would break the rhythm, alerting the reciter to a mistake. This ensured that the knowledge, from intricate philosophical concepts to detailed astronomical observations, was transmitted with flawless accuracy. Similarly, the Epic of Gilgamesh was not just a thrilling adventure. Its structured verses acted as a mental filing cabinet, preserving cultural values, historical encounters, and vital geographical knowledge of Mesopotamia. This method of storage was incredibly resilient. A clay tablet can shatter, a library can burn, but a story, living in the minds of an entire community, can survive wars, migrations, and the collapse of empires. Polynesian navigators did not carry parchment charts. They learned the star paths through chants that named hundreds of stars and described the precise sequence of their rising and setting over specific islands. These chants were the living GPS of the Pacific, a dynamic database updated by each generation of master navigators and taught to apprentices through song. This reveals a profound truth about our ancestors. The absence of a written record in a culture does not indicate a lack of knowledge. It signifies a conscious choice or a cultural mastery of a different kind of technology, one that is fireproof, waterproof, and travels light. They invested not in ink and paper, but in the trained human mind, creating a living, breathing archive that walked and talked, ensuring that the most vital secrets of the cosmos would never be truly lost. High in the Yucatan jungle, a pyramid casts a shadow that transforms with the seasons. El Castillo at Chichen Itza is a masterwork of Mayan archaeoastronomy, a massive stone calendar designed to interact with the sun. On the spring and autumn equinoxes, the play of light and shadow creates the illusion of a serpent slithering down the northern staircase, a representation of the feathered serpent god Kukulkan. This was no coincidence but a precise calculation in stone, aligning the pyramid's 9 terraces and stairways with the solar year. The Maya did not merely mark days, they conceived of time on a scale that staggers the modern mind. Their long count calendar was not concerned with short cycles, but with vast epochs, tracking time in units called backtons, each one spanning 144,000 days. A full cycle of 13 backtons amounts to over 5,125 years, a grand cycle that famously ended and reset in the year 2012 of our own calendar. This was not a prediction of doom, but the completion of a great cosmic age, a testament to their belief in the cyclical nature of creation itself. To measure such immense spans required generations of meticulous observation, a continuity of knowledge preserved by a priestly class who saw the universe as a great ticking clock. Far to the south, on the arid plains of Peru, an entirely different kind of celestial art was being drawn. The Nazca lines are a collection of giant geoglyphs sprawling across hundreds of square miles of desert floor. From the ground, they are meaningless scratches, but from the air, they resolve into perfect geometric shapes: a colossal monkey, a hummingbird, a spider. Their purpose has been debated for decades, but a compelling theory connects them directly to the sky and the Earth's water. Many of the long, straight lines point directly to the place on the horizon where the sun and other celestial bodies would rise or set during significant times of the year. Others seem to align with subterranean water sources, mapping the hidden veins of the desert. By walking these lines during sacred ceremonies, the Nazca people may have been performing a ritual of alignment, connecting the celestial patterns above with the life-giving waters below, a form of geomancy that sought to maintain the balance of their fragile world. These American achievements stand as powerful, independent confirmations of a universal human drive, separated by continents and oceans from the builders of Stonehenge and the pyramid makers of Egypt. The Maya and the Nazca arrived at the same profound conclusion, that humanity's place in the world could only be understood by measuring our connection to the cosmos. A single stone, shaped like a beehive and carved with a net-like pattern, sat in the temple at Delphi. The Greeks called it the omphalos, the navel of the world. They believed it marked the very spot where two eagles, released by Zeus from opposite ends of the earth, had met at its center. This was no isolated myth. From the Holy of Holies in the Jerusalem temple to the sacred pyramid at the heart of Teotihuacan, cultures across the globe designated a specific location as the Axis Mundi, the world axis. This was the central pole around which the cosmos turned, the point where heaven, earth, and the underworld met. It was a profound act of world building, a way to impose order on the formless chaos of existence by declaring a center. But this was more than just a spiritual idea. It was a practical, geodetic anchor. Establishing this central point was the first and most crucial step in organizing the physical landscape. From this sacred center, the world could be divided into 4 quarters, the cardinal directions could be established, and the entire cosmos could be mapped onto the land. The axis mundi was the fixed pivot, the unmoving point from which all measurement and meaning radiated outward. This pattern repeats with stunning consistency. For the ancient Norse, the world tree Yggdrasil was this axis, its roots in the underworld and its branches in the heavens. In India, Mount Meru served the same cosmic purpose, a colossal peak at the center of the universe. The symbolism is always the same, a connection point, a conduit for divine energy flowing between realms. By building their most sacred temples on these perceived centers, our ancestors were not just constructing buildings. They were staking a claim to cosmic order, creating a focal point where human society could align itself with the eternal turning of the stars and the deep, stable power of the earth itself. The same geometric precision used to map the stars was turned downward to the life-giving pulse of water itself. In the arid heart of Persia, a hidden network of tunnels called qanats stretched for miles beneath the desert surface. This was not a simple ditch. It was a masterwork of underground surveying, a gently sloping channel carved through rock and soil to tap into distant mountain aquifers and guide the water by gravity alone to the parched plains below. The builders had to maintain a perfect, consistent gradient over vast distances, a feat requiring an advanced understanding of leveling. A single error in calculation, and the water would either stagnate or flow with such force it would erode the tunnel walls. This was applied sacred geometry on a grand scale, a deliberate reshaping of the hidden earth to sustain life above. The Romans took this terrestrial engineering to its most spectacular heights. Their aqueducts marched across the landscape on towering stone arches, defying gravity to deliver fresh water to bustling cities. These were not just bridges for water, they were monumental declarations of human will. The project began with the surveyor's rod and level. Teams of workers had to measure elevation changes with painstaking accuracy across dozens of miles, ensuring the channel would drop at just the right rate, a hand's breadth every 100 feet, to maintain a steady, controllable flow. The construction itself demanded a mastery of structural engineering and the Roman concrete that could set underwater, creating a seamless, pressurized conduit. From the subterranean qanat to the elevated aqueduct, the fundamental principle was identical: a rational, mathematical control over the natural world. This was the ultimate power granted by their cosmic science, the ability to not just observe the harmony of the universe, but to actively install it within the human realm. Bringing order to the chaotic flow of water was a direct parallel to bringing order to the cyclical motions of the heavens. Both acts required measurement, foresight, and a deep faith in the underlying logic of creation. This was humanity learning to write its will upon the world, not with words but with water and stone. The scattered stones of our ancient world whisper a tantalizing possibility. From the stark plateau of Giza to the high Andes, and across the lonely moors of Britain, megalithic wonders share a mysterious family resemblance. They are built with a staggering scale, a precision in stone cutting that seems to arrive suddenly, and a common obsession with celestial alignment. This undeniable pattern has fueled one of history's most enduring and controversial questions. Could these monuments be the scattered children of a single, forgotten parent civilization, a sophisticated culture lost to some great cataclysm in the deep past? The arguments for this idea are built on a foundation of curious parallels. Consider the pyramid itself. This iconic form appears not just in Egypt, but in Mesopotamia, in the stepped pyramids of Mesoamerica, and even in ancient China. While their styles differ, the underlying geometric and astronomical principles feel strangely consistent. Then there are the global flood myths, stories of a world-destroying deluge found in hundreds of culturally isolated traditions. Proponents of a lost civilization see this not as coincidence, but as a shared, traumatic memory of the rising seas at the end of the last ice age, an event that could have wiped the slate clean for a coastal-based advanced society. The most compelling evidence, however, may lie in the stars. The apparent knowledge of the precession of the equinoxes, a cycle so slow it takes 26,000 years to complete, suggests an unbroken lineage of astronomical observations spanning millennia. How could cultures supposedly discovering agriculture independently also develop this incredibly long-term, unified vision of the cosmos? The lost civilization theory offers a seductively simple answer: a golden age that provided the seed knowledge to all subsequent cultures. Yet mainstream archaeology remains deeply skeptical, and for strong reasons. There is no smoking gun, no physical evidence like tools, settlements, or DNA that conclusively links the builders of Göbekli Tepe to those of Sacsayhuaman. The pyramids of Egypt and Central America are separated by thousands of years and vast oceans, their construction techniques and cultural contexts entirely distinct. The flood myths could simply be a universal human response to the very real, local catastrophes that every river-valley civilization eventually faces. And the astronomical knowledge could have been independently developed by many cultures over time, each patiently watching the same sky. The theory persists not because it has been proven, but because it addresses a profound unease. It tries to solve the puzzle of why human ingenuity seems to burst forth in certain places and then fade, and why the oldest layers of our history often contain some of the most technically baffling achievements. It speaks to a romantic notion that we are not the first to reach for the stars, that a wiser, more unified human world once existed, leaving behind only cryptic stone messages for us to decipher. Whether myth or history, this idea forces us to look at the ancient world not as a collection of isolated wonders, but as a single, unsolved mystery. The tools of the master builder became the emblems of a hidden philosophy. In the quiet halls of Freemasonry, the square and compass are not merely relics of a stoneworking past. They are living symbols of a much older tradition, a potential bridge across the centuries connecting medieval guilds to the mystics of antiquity. The square represents morality, the compass defines spiritual boundaries, and the plumb line signifies the upright pursuit of truth. These were the same tools used to raise the great cathedrals, structures whose very foundations were laid out with sacred geometry, aligning their naves and altars with celestial events. The medieval stonemasons' guilds were more than labor unions. They were custodians of a profound secret, that the act of building a physical temple was a mirror for the greater work of constructing a virtuous and enlightened self. This was the master builder's dual craft, to shape both stone and soul according to the same universal principles of order and harmony. The historical threads linking these guilds directly to the pyramid builders or the designers of Stonehenge are woven more from legend than from documented fact, and yet the philosophical resonance is undeniable. The persistence of these symbols and their associated rituals suggests an unbroken, if underground, river of knowledge. This hidden current flowed through the Renaissance and into the heart of modern esoteric societies, who continue to study the hermetic principles of as above, so below. They kept alive the idea that humanity could consciously participate in the cosmic order, not by erecting new stone monuments, but by applying the ancient blueprint to the inner landscape of the human spirit. The flame of this ancient wisdom, carefully guarded and passed from initiate to initiate, may have flickered, but it was never fully extinguished. It reminds us that the most profound constructions are not always made of stone. These disparate threads of evidence weave together into a new and compelling story of our past. We have not been looking at isolated marvels, but at chapters in a single, sprawling epic of human discovery. The ancient impulse to measure the Earth and map the stars was far more than a collection of local superstitions or practical needs. It was a long-term, collective human project, a recurring theme of intellectual and spiritual inquiry that spanned millennia. From the rope stretchers of Egypt to the stargazers of Choco Canyon, diverse cultures were participating in a grand, collaborative experiment. Their shared goal was to understand humanity's place within a vast, ordered cosmos and to build that understanding permanently into the world around them. This was not a single, unified science with a central command, but a shared pattern of thought that blossomed independently yet harmoniously across the globe. They used the universal languages of mathematics and geometry to translate celestial order into terrestrial form, creating monuments that served as both observatories and philosophical statements. This perspective does not diminish their individual cultures, it elevates their collective achievement. It asks us to see our ancestors not as primitive people stumbling toward enlightenment, but as pioneers of a different kind of science. Their methodology fused empirical observation with spiritual insight, seeing number and nature as two sides of the same sacred reality. They were building a bridge between the human spirit and the cosmic mind, using stone and alignment as their materials. This grand narrative suggests that the true purpose behind the pyramids, the stone circles, and the sacred cities was to create a resonant harmony between heaven and earth. They sought to anchor their societies to the eternal rhythms of the universe, believing that a world built in cosmic alignment would be a world of balance, fertility, and divine favor. This was the great work, a project so ambitious that it required the dedication of centuries and the coordination of knowledge across generations. The evidence is no longer in scattered fragments. It forms a coherent picture of a deep human yearning to comprehend the cosmos and to leave behind a permanent record of that understanding, a message in stone waiting for us to finally read it in full. Our journey through these unearned patterns reveals a portrait of ancient humanity far more brilliant and interconnected than our history books ever suggested. From the stone circles of Britain to the pyramids of Mesoamerica, we find a recurring testament to an insatiable human drive, a shared impulse to measure the earth and map the stars. These forgotten builders were not merely laborers hauling stone. They were the astronomers, the mathematicians, and the philosophers of their age, using the language of geometry to inscribe their cosmic understanding into the very bones of the landscape. Their legacy is a profound challenge to our modern assumptions. It asks us to look at the scattered stones of our past with fresh eyes, to see them not as isolated ruins but as pages from a lost global epic. This story teaches us a humbling and thrilling truth that profound knowledge can indeed be lost, buried by the sands of time and catastrophe, only to be patiently rediscovered by future generations. Let this exploration be an open invitation to keep questioning, to keep exploring, and to never stop marveling at the hidden depths of our shared human story. We would love to hear your thoughts on these enduring mysteries in the comments below, and if you wish to continue this journey of discovery, subscribe to join us as we uncover more secrets from our forgotten past.